Then the previous example we looked at, if we have 8 people racing and we want to award first, second, and third place on it, then we said we would have 8 times 7 times 6. And I want to point something out really quick before we go any further, and that is if I wanted to award a 4th place, then I would be adding in another number, right? Well, I had 8 for first, 7 for second, 6 for third, and I'm guessing you can probably figure out I would have 5 people on the track to award 4th place too. If I wanted to add in a 5th place, suddenly I'd have 4 people, right? A 6th place, I would have 3, and so forth. And at this point, we can see that what we're really hinting at here is this idea of factorials that we talked about before. So our goal is to come up with a formula based on this that will help us figure it out anytime we're given a certain number of people, how many different ways can we make an ordered arrangement of this other number. To do this 8 times 7 times 6 almost looks like 8 factorial, right? And I'm going to put like this equal, but it's not actually equal to. And it's not actually equal to because 8 factorial is actually 8 times 7 times 6 all the way down. And so when I look at comparing these two, what I actually had up here to what I should have if this was 8 factorial, I want you to notice I'm missing some numbers, right? That is, this 8 times 7 times 6 is missing this entire section right here. And so what I need to do is I need to cancel that out somehow. Well, looking at it here, I need to figure out how do I cancel out a 5, 4, 3, 2, and 1. One way of thinking about this is maybe I subtract off. However, I know that subtraction doesn't cancel out multiplication, right? So that's actually not going to work. The way we cancel out multiplication is to divide. So rather than subtracting off, I'm going to go ahead and divide this by 5, 4, 3, 2, and 1. The reason I'm doing this is I'm trying to make this bottom thing look like what I have up here. So if I take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 and divide that off, then sure enough, all this junk right here would cancel, right? And I'd end up with exactly what I wanted. The question here is, what am I dividing by? What is that 5 times 4 times 3 times 2 times 1? And well, since we're on the idea of factorials already, what I'm actually doing here is I'm dividing by 5 factorial. So, moving back up one step, this is not equal exactly to 8 factorial. Rather, it's equal to 8 factorial divided by 5 factorial. If I divide it by 5 factorial, it will cancel out all this extra stuff that I didn't actually want, leaving me right here with exactly what I have up here. The question becomes then, okay, awesome, so this entire thing then is 8 factorial divided by 5 factorial, but where is this 5 factorial coming from? In order to look at that, we need to go ahead and reflect on some of the notation we've used in the past.